Hello, this is Samuel Starr presenting the physical validation and logic structure for Lab 5, implementing emergency stop and fault handling safety architectures. Our primary objective is to engineer a deterministic safety layer around the multi-state automatic sequencing project we developed in the previous Lab 4. Before looking at the code, it is vital to note our mechanical parameters. This target SMC station utilizes single-acting spring-return directional control valves. This means our cylinder actuators only extend or activate when their respective solenoid coils are actively energized by a high logic state from our Siemens controller. If power is dropped, an internal mechanical return spring instantly forces the valve spool back to default, exhausting the working air pressure. To ensure that our protective interlocks maintain absolute precedence over our machine operations, the block architecture within our main organization block, OB1, is selectively tiered. As documented on screen in Network 1, our safety block kernel is called on the very first execution line of the controller's cycle sweep. This intentional sequence positioning guarantees that the PLC evaluates inputs, safety status latches, and updates internal system health flags on every scan cycle before any sequencing or actuator driving block is permitted to process a motion command. Now let's observe the physical system override path during a live execution. When the station is cycling automatically and the hardware stop button is depressed, an immediate master memory purge is initialized. The logic instantly clears the sequence bit footprint from step 1 through step 8, terminating all automated looping parameters. However, look closely at the physical hardware. Because dropping power to a single acting solenoid would cause a catastrophic vertical drop or part collision, our safety block latches an internal software lockout flag. This flag maintains an emergency holding loop to the active physical output terminals, keeping the valve coils energized and pinning the arm in a safe, static, frozen position mid-stroke. Once an emergency stop event is triggered, the PLC enters a strict, non-hazardous software lockout layer. Even when the physical stop button is released, pressing the start button has zero effect on the station, mitigating any risk of accidental restarts while an operator clears components. To recover from this state, our code requires a deliberate manual operator protocol. The physical auto manual selector switch must be cycled through exactly 3 discrete edge transitions. On screen, you can see our up counter block incrementing on each switch transition. On the third rising edge, the counter reaches its preset limit and fires a single scan reset pulse. This pulse drops our emergency holding loop, clears the system lockout flag, and safely removes electrical power from the coils. The return springs take over, cleanly venting air pressure to return all cylinders smoothly back to their default home coordinates.